Hello students and welcome to Smartkidz tutorials. In this video we'll be learning the whole chapter of our environment. When we speak about our environment, we include everything that surrounds us. That includes living as well as non-living. Living things, you know what they are. Non-living things would include like your computers, your chairs that you sit on, table, bed, whatever, something that does not have life. Whatever has life, what we call living things, they are known as biotic, and whatever is non-living, we call it abiotic. They are biotic and abiotic components of what we call as an ecosystem. So all these comprise what we live in. These are our surroundings, and this is what makes our environment. Our environment shapes our lives in many ways. It affects our life and even the development. It depends. Those who live in climates which are extremely hot and humid are different than those who live in climates which are extremely dry and arid, as in the Gulf region, or for that matter those who live in areas where it's always cold, like in Europe, okay, especially Northern Europe. Not only humans, the plants, other animals, they all are different compared to different and that depends on basically the climate they live in, the environment they grow in. So the environment influences our growth and development in a huge way. Those who surround us, what we grow up with, that really influences our growth and development. Now, apart from those that are living, when we die or when anything becomes dead, then there has to be something to decompose it, as in to break it down. Imagine a rat lying there forever, a dead rat. How it would that be? Or rather, a dead rat, after some time, it obviously smells bad after some time, but then this rat slowly shrivels up or die after death, decomposes, and slowly what we see are just the bones that are left. Same thing happens with humans, same thing happens with all dead organisms. Okay, what remains are the parts which take time to decompose or to disintegrate. So but all of them do not decompose. There are substances, particularly man-made, which do not decompose, and these we call as non-biodegradable. What gets decomposed, we call it as biodegradable. That is something that is broken down to very simpler materials. Ultimately, we are made up of all the major elements, that is carbon, hydrogen, oxygen, nitrogen. We need when we die, our bodies, tissues, organs, cells are ultimately decomposed and broken down to this simpler molecules. Okay, and the soil takes it up and then gets recycled again. Similarly, there are other materials, particularly like man-made materials like plastic and so forth. These, though they are made up of simpler materials, they are complex and not easily broken down by natural processes. And natural processes would include rain, heat, all these things affect how quicker or how long it takes for any material to be broken down. That is a natural process. Naturally, substances like plastic take extremely long time to decompose or to degrade, like humans. Well, the problem in that is that we are using plastics at a tremendous rate, and we use and we throw, discard. When we throw and we discard, we should know that this plastic is going to take a huge amount of time to decompose, which means these plastic, and when I say huge amount of time to decompose, they don't decompose in our lifetime. So you imagine if our generation keeps using this plastic and throwing them off, then what will happen is this plastic will double up, triple up. Okay, it will keep mounting. Where are we going to keep this plastic? Right now, in around the world, there is a problem, not just growing problem, not just of plastic waste, but waste in general. How to manage that waste? How to decompose the waste? The waste has become so much because the amount that we are consuming is huge, and we are consuming packaged products mostly. Okay, gone are the days where we used to uh, use organic products. Now organic products we have to pay more. Okay, something that we shouldn't be paying more, but we are paying more. They get branded as organic products grown organically because they can be decomposed. But that then there are materials which cannot be decomposed, like the plastics. Okay, like they are reused or recycled, then it's fine. But overall, our general concept is what? Use and throw. Now, if we use and throw such plastics, how are we going to manage this waste? There are some examples of biodegradable materials, okay, that you may see, as well as non-biodegradable materials. And you see, the biodegradable materials include fruits, hair, papers, which is made up of trees. Non-biodegradable materials include plastic bags, some computer hardware, bottles, some examples. Okay, so one must be aware of which are biodegradable materials and which are non-biodegradable materials, and use them judiciously. Ecosystem and its components. So we need to know what is an ecosystem and what are its components. All the interacting organisms in an area together with non-living components form an ecosystem. That's what I spoke about in the first slide. Everything in the environment, which includes biotic as well as abiotic components, that comprises our ecosystem. Okay, and this will include even things like temperature, rainfall, wind, soil, etc. An ecosystem can be further divided, as you see over the chart over here, which can be man-made or natural. Man-made, as you can understand, is something that is done by humans, okay, for commercial purpose or looking into development of a habitat for a particular organism or group of individuals. In natural ecosystem is what we find everywhere, and that can be further classified into aquatic ecosystem as well as terrestrial. Terrestrial refers to the land ecosystem. That would include forest, desert, grassland, etc. Okay, and aquatic ecosystem would include a marine ecosystem, freshwater. Marine is referring to the salt water, and freshwater, of course, something that is not salty. That would include your ponds, rivers, lakes. Marine ecosystem would include sea and oceans. So this is just classification of where you will find living as well as non-living components. Here are some examples that you can see and identify for yourself. Artificial ecosystem, natural ecosystem. So artificial ecosystem, a garden. A garden is not a natural ecosystem, but is deliberately or purposefully crafted for people for aesthetic beauty. You have aquarium, again, something that we, for our personal pleasure, we keep fish over here different time. You may have aquarium, a small aquarium in your house or in your at your business place, or we have aquariums, large scale aquariums, which attract tourists to have a look, something that they can't see in day-to-day life. Crop field, okay, again something that is developed by humans for agricultural purposes. And zoo, okay, development of a forest ecosystem by humans for wild animals or animals that you will find scattered everywhere, you will find in one place for people to view them. And also zoo is not just a place where animals are held captive. Sometimes they are kept there to keep them protected as well if they are part of endangered species. Natural ecosystem, of course, the forest, ocean, lake, and desert. So uh, the artificial ecosystems that humans develop are by taking ideas from our natural ecosystem. So they try to develop these systems in places where otherwise naturally they would not be found. All living organisms are classified on the basis of the manner in which they survive in the ecosystem. Okay? And this would refer to uh, what they feed on, how they interact with different individuals, their interaction, whether they eat some individuals or they are eaten by some individuals and so forth. So we'll go through them. First ones are producers, as the name suggests, they produce. That would include only the plants, okay, because they are the only ones that are producing. They use sunlight in order to produce their own food, and they in turn serve as food for all other individuals who are referred to as consumers. So they produce their own food, the producers I mean, produce their own food, that is sugar and starch, by sunlight, which we call as photosynthesis. The rest all fall under the category of consumers. Of course, there are decomposers as well. We'll come to that later on. But most of them are consumers, consumers who consume producers and other consumers. Under consumers, there are various other categories as well. Okay, so these would include herbivores, carnivores, then you have parasites, and you have omnivores as well. So we go through each one of them. Herbivores are those which are grass eaters, like your deer, cow. They don't eat other animals, they just eat grass, where they feed exclusively on producers, and that is why they are known as herbivores. Then you have carnivores are those who feed exclusively on other animals. They don't eat grass or vegetables or anything, just meat, flesh eaters. This includes lion, tiger, and so forth. Then you have, I will go to omnivores first, then come to parasites. Omnivores are those that feed on both plant as well as flesh. And here example is given as crow, who are scavengers. But even humans, excluding those who are vegetarians, consume meat as well as vegetables. So vegetables are plants, right? So humans are regarded as omnivores. Then you have a fourth category under consumers known as parasites. So parasites feed on live animals, and sometimes they feed on dead animals as well. Okay, so they have a host body. Here example that is given is feeding on host body, that's of Plasmodium, a protozoan which is responsible for causing malaria in us. Of course, we have mistakenly most of the time say that malaria is caused by mosquitoes. It is not caused by mosquitoes, it's caused by this Plasmodium. Mosquitoes just act as vehicles in which they travel and get transferred. Okay, of course, mosquito is a culprit in this, because it is only when it bites then the Plasmodium is transferred into us. There they multiply using our blood and lead to a condition called as malaria or dengue also. Third, the decomposes. Okay, so we had the producers, the consumers, and the decomposers. These exclusively feed on dead decaying matter. Okay, completely on dead decaying matter. These so dead plant, animals. Okay, but most importantly, they play a significant role in the environment because they break down complex material into simpler ones. Okay, simpler molecules. Remember, we living individuals are made up of complex molecules, where simpler molecules get together to form complex molecules. This, when we die, These complex molecules need to be broken down to simpler molecules so that the soil can utilize it, and other individuals, organisms, living organisms can derive this nutrients. So uh, this can go back into the soil, including what is in it, because we are made up of simpler molecules, okay, at the very molecular level. So these decomposers help in replenishment of the natural resources, okay, to help to give back to the environment. So it's kind of law, it's they follow kind of law of conservation of nutrients. Nutrients are not destroyed, but rather they are transformed from one form to another, and what is present in the complex form at the macromolecular level in living individuals is broken down to micronutrients, the simpler molecules, which are then available for plants and other organisms that may be present in the soil. Here you see the difference. Producers which make their own food include plants, consumers which eat other organisms for food, that includes your herbivores, carnivores and omnivores, and then you have the decomposers which break down dead material exclusively. Food chain. Okay, now the name itself suggests that we are talking about a chain that is formed, and that chain is of food. So food that is being kind of passed on from one level to another level. But rather here individual components or organisms are part of the food chain, which means they serve as food for someone higher than them. Okay, so that is what we refer to as food chain. The food chain refers to an arrangement of different biotic groups. So this refers to only living individuals, biotic groups in a sequence of energy transfer. These biotic groups are producers, herbivores, carnivores, okay, and would include omnivores as well. In this food chain, these biotic components transfer energy from one form to another. So when one individual consumes another individual in this food chain, the energy that is there in the individual that is consumed by a higher organism gets transferred to this higher organism, and this in turn serves as food for some other, or transfer also, you can say, leads to transfer of energy from one individual to another. However, what is also seen in this case is that when uh, when energy gets transferred from one lower individual lower down the food chain to an individual which higher up the food chain, energy decreases, and we'll see that how that happens. So green plants capture 1% of the sunlight that falls on their leaves. Okay, these are the producers which produce their own food, that is sugar and starch. Okay, they don't depend on any of the consumers. The flow of energy is unidirectional in a food chain. Unidirectional means it flows in one direction, it doesn't go back. So it starts with the producers all the way to the consumers. From consumers, it doesn't go to the producers. There is gradual decrease in the amount of energy transfer from one trophic level to the next trophic level in a food chain. And that's what I was talking about. The trophic level which we are talking about here is with respect to consumption of an individual or organism that is lower down the food chain, and of that by the when consumption of a organism that lower down the food chain by an organism that is higher up the food chain, and that refers to a trophic level. We'll see that what it is. Okay, here you see this is a food chain, and in this food chain, if you notice, you have the producers, which is grass, which is eaten by a consumer, that is grasshopper, which is exclusively a herbivore feeding on us, but that is referred to as a primary consumer because it's the first consumer. Then you have this grasshopper which is consumed by a frog. So because this frog is consuming the primary consumer, it becomes a secondary consumer in this food chain. Frogs are obviously consumed by snakes, who then become the tertiary consumers in this food chain. And you have hawks which prey on snakes, they become the final consumers. Okay, and when these individuals die, okay, then what happens is they get decomposed. So not yes, of course this would cycle would continue, but this arrow can apply over here as well, from here to here, from here to here, or from here to here as well, and even from here to here, because decompose everything, not just consumers, even producers. Okay, so that applies to everywhere, and they are kind of part of that, and they give it back to the environment, and then this cycle would continue actually over here. Okay, giving it back to the producers because it decomposes and it gives back to the soil. Now here you've been given a fungi, a mushroom, you can see it decomposes, fungal. But there are other decomposers as well who do the similar job of decomposing and breaking down the complex molecules to simpler molecules. We were talking about trophic levels. So these are the trophic, this is how in the form of a pyramid, this is energy level that shows you producers are right at the bottom. One step on top is primary consumers, on top of that you have secondary, then you have tertiary consumers. But at each level, if you notice, right at the bottom, producers, just an illustration that is shown to see to show you how energy decreases as you move from the producers to the tertiary consumer. So you have 1000 kilojoule of energy for the producers, which reduces to become 100 kilojoule. Okay, there's a decrease of 10% here, and then from 100 kilojoules to from primary to secondary consumers it becomes 10 kilojoules, again a 10% reduction. And then from secondary consumers to tertiary consumers there is a further decrease in the flow of energy by 10%, wherein it reduces from 10 kilojoule to 1 kilojoule. So as you move from a lower trophic level to a higher trophic level, the flow of energy actually decreases. Okay, and at each step it is found to be decreasing by 10% roughly. Okay, so 90% of energy is basically used up by the time it reaches right on top. Okay, and remember, only a small amount of energy that is trapped by the producers from sunlight, just 1%, as we have seen. So you see, though that is 1% is good enough to carry out to provide energy required for to carry out various life processes for the producers, and the energy that is transferred successively is also sufficient enough. So the loss of energy at each step is very high, and so very little energy remains after 4 trophic levels. So that is why you see the population right at the bottom is far more compared to the population right at the top. Okay, that is there are a lot of more plants than there are tertiary consumers. Biomagnification, okay, a term that is used to describe the increasing concentration of harmful chemicals in each trophic level in a food chain. That is called as a biomagnification. Here you can see how the concentration level of harmful chemicals increases. Here we are speaking about DDT, okay, which is a harmful chemical which accumulates in individuals. So DDT coming from application of DDT in fields or water, or maybe dumping of chemicals by as effluents by chemical industries in the water, and this is taken up by microorganisms in the deep in the ocean called as zooplanktons, which are consumed by small fish. Small fish consume the big fish, and each and every step okay, there is further accumulation of this DDT. If you see, this is parts per million. Accumulation is in terms of parts per million. This is a very small quantity. Then it goes on to become 0.04. Then it is 0.5. There is 2 parts per million in a bigger fish. Then in the case of a hawk, it is 25 parts per million, and then that increases further. So imagine a human consuming fish on a regular basis, how much of this DDT would be accumulating, and at a later stage it causes a lot of problems including cancer and so forth. Okay, so maximum concentration of such chemicals are seen accumulated in human bodies. This is referred to as biomagnification, the accumulation of this harmful or concentration of this harmful chemical in respective individuals or in respective food chain levels. This is a food web. Okay, just like a food chain, we have something called as a food web. It just tells you how one individual is a meal for another. Okay, and how different individuals, okay, are interrelated to each other very intricately. So the food chains are interconnected with each other, forming a web-like pattern, which is referred to as a food web. So you have a look at this. Say we'll look at this part first. You have a tree. The giraffe feeds in the tree, okay, and the lion would feed on the giraffe as well as on the rhino. Rhino also would feed on the grass and trees. So you see, this is they form one of them. But over here, then it diverges further. You have grass over here, which is being which serves as food for a deer. Deer serves food. It's an impala, family of the deer, and here it serves the impala serves as food for the leopard. Leopard on the other hand serves as food for the vultures. Vultures, you know, feed on dead matter. So vultures don't catch live animals, especially not live leopards, who are very quick. When they die, the vultures feed on them. And similarly, you have other web patterns over here, wherein you have grass, and then there's a grasshopper feeding on the grass, and this grasshopper would be fed by on a bird and also by a baboon. A baboon would be fed on by or would be eaten by a leopard. Okay, and the cycle continues this way. If you go this way, it's the grasshopper is eaten by this bird. This bird is caught by this African skunk, yes, and upon death of this skunk, the vulture would feed on. Again, the vulture would feed even on a rhino or on a lion or on a. They are scavengers, so they eat on dead, decaying matter. Anybody who's dead, they feed on that. Okay. And shrubs from here also end up in this food web. So food web basically is a relationship of different living organisms within a ecosystem. Environmental problems. So when we speak about our environment, there are surely going to be environmental problems. Environmental problems which are man-made. Okay, and this is something that is uh, now becoming more and more worse. Okay, in the name of development, we are destroying our environment. We need to understand, without the environment, without these trees, without the ecosystem, okay, humans cannot survive. Certain individuals within the ecosystem, we may not know their worth till they vanish from the system. And how are they vanishing from the system? Because we are destroying their habitat, we are destroying their food. How are they going to survive? They're not going to survive. If the balance is destroyed, then it is obviously going to affect us. It is affecting us. You may see that there is unseasonal rainfall Sometimes it is extremely hot, sometimes it's extremely cold. Okay, different parts of the globe are experiencing different problems. So here we look at the changes in environment that affect us. Our activities change the environment around us, and this has led to the slow degradation of environment that has given rise to many environmental problems. We'll see only a few of them. So example includes depletion of ozone layer and waste disposal problem. The depletion of ozone layer. See, ozone is a three molecule. It's actually oxygen, but it's three atoms of oxygen forming an O3 molecule, and that ozone is actually poisonous at our level. That means if we consume ozone, that would be poisonous for us. But this poison actually serves as a protective layer in the above the atmosphere, protecting us from harmful chemical rays or UV rays which come from the sun. So largely found in the stratosphere, which is part of the atmosphere from 12 kilometers to 50 kilometers above sea level. Deadly poison at ground level, formed as a result of photochemical reaction. Here you may see there's the sun and there's a radiation level, and this UV radiation, and it protects us from that. Just between the stratosphere and our atmosphere, it forms this layer which is there. Now there are certain chemicals which are making holes in this ozone layer, which would allow penetration of this harmful rays to reach us. That would cause mainly skin cancer. So ozone layer is a protective blanket around the earth which absorbs most of the harmful UV rays from the sun, thereby protecting living beings of the earth from health hazards like skin cancer, cataractitis, weakened immune system, destruction of plants, and lots other problems can be encountered if this ozone layer is destroyed. Decline of ozone layer thickness in Antarctica was first discovered in 1985. So this process has already started. Okay, and we are making the hole wider and wider. We are actually digging our own grave. That's all, and termed as an ozone hole, the hole which is called. Reason for ozone depletion: excessive use of a chemical called as chlorofluorocarbon, synthetic inert chemical, example freon, which are used as refrigerants and in fire extinguishers. A lot of these chemicals are used in refrigeration and also as fire extinguishers. Single chlorine atom can destroy 1 lakh ozone molecules. See the power of that. And United Nations Environment Program has been doing a very excellent program in getting the nations together, making them understand the seriousness of the issue and trying to curb the use of this chlorofluorocarbons and other similar destructive chemicals that could destroy this ozone. There was a protocol that was signed by most of the nations called as the Kyoto Protocol, and there's a follow-up going up in this, and more nations are growing aware of this situation. They can now see what can happen if the ozone layer is destroyed, if there is an imbalance in the environment. Coming to the next problem, that is garbage disposal. This is a problem of industrialization, commercialization of everything. Before, we didn't have this problem. Growing population, growing consumerism are have caused this problem of growing garbage. There are a lot of people consuming a lot of things. Plus, growth in affluency, that means ability to spend more and purchase more, has led to this garbage disposal problem. This is not a problem just of India, but is a problem throughout the world. Garbage disposal is a huge and major problem around the world. People do not know how to manage the garbage. Okay, and we are a root cause for it. First of all, if we do not generate garbage, we won't have to think about managing it in the first place. We do not know how to stop producing garbage, and we do not know how to manage garbage as well. Okay, and not many are aware of how much damage garbage non-disposable of garbage can cause to the environment and to the health of individuals. This garbage disposal problem is mainly seen in urban areas, but now is also being felt in rural areas as well. Different methods of solid waste disposal that are used around the world include open dumping, where you dump conventional is solid waste is dumped in particular area. One particular area is designated, and there all the waste is usually outside the city. It causes pollution, but somewhere the garbage has to go till it is disposed of by the next step. That is, it could be by composting, recycling, maybe incineration, whatever. Landfillings, wastes are dumped in low living area and are compacted by rolling with bulldozers. So you see over here, you will see waste compaction is done. Okay, and this is a landfill. You may be familiar with this. Okay, where all garbage from all around the place will be dumped on designated spot is given. Composting is something that you can do in the house. All the vegetable waste, some fish waste, maybe some other cleaning, something that is especially degradable, okay, biodegradable. This is something that you can do and use in your gardens as well. So organic waste are filled into a compost pit. It is then covered with a thin layer of soil. After about 3 months, the same garbage filled inside the pit changes into organic manure. Instead of buying an organic manure, you can make one. Okay, if you have a small garden, you can definitely make one and use that organic manure. Very extremely good to grow your vegetables, fruits. You can put it for your various plants as well. Yeah, absolutely natural. Everything is organic about it. So then you also have recycling, and recycling is something that is being promoted on a large scale nowadays, especially for plastic waste. uh, Here you will see, okay, this waste compaction actually goes further for recycling as well. So the solid waste is broken down into its constituent simpler materials, and these materials are then used to make new items. Even non-biodegradable solid waste like plastic and metals can be recycled. So even like cans, your Coca-Cola cans and thumbs up cans, okay, these can be used, recycled and used further. And the most important part is reuse. I feel if you try to reuse most of these plastics, a lot of this plastic problem can be solved by just reusing. We tend to just use and throw, okay, but a very simple conventional technique of using again and again. Okay, like for example, give you example, you have plastic bottles. We can make use of plastic bottles by growing something into that, okay, making some craft out of that. Okay, you can even store like oil in that plastic bottle. At least use it for some time rather than just using and throwing it out. Preferably, I would say not to use plastics at all. Avoid plastics. Use of plastics as and where possible. Okay, but if you have to throw it out, think about reusing it at least for some period of time. Okay, paper can be, but paper is biodegradable. So even if you throw it out, it can degrade itself. It can get degraded. Paper, but however, can be reused. There are many things that can be reused. Okay, it's up to you whether you wish to reuse it or not. Some other methods that I use are incineration. So you have this garbage in the landfill. Sometimes they are compacted and incinerated as well. Then biogas generation is another one that can be used. Vermicomposting is another method that can be used in order to deal with this solid waste. So these are some methods that are used, for solid waste disposal. Okay, and these are the two problems. That is ozone depletion and garbage disposal, which is a major problem these days. causing a lot of harm to the environment. So with this, we complete the chapter of our environment. If you've liked watching the video, please hit the like button, share it with your friends and classmates. Please subscribe to the channel if you haven't done so, and keep watching for more such videos. Thank you for watching.